Hi everyone, welcome to AI Crack channel. This is Akash Gangwar and today we'll be studying progressions lecture 1 and we'll be talking about basic stuff regarding arithmetic progressions. Okay. So let us begin our lecture with the basic definition of AP, and I'm assuming that you have gone through this back in your 9th and 10th class, 11th, 12th class, JE syllabus, CAT syllabus and now in PGDBA syllabus. So this is not new to anyone, right? So I'll not be spending too much time explaining the basics. We'll quickly go through the basics and then move on to the problem solving, right? So let's start with the basic definition of AP over here. So AP is a sequence whose terms increase or decrease by a fixed number. This fixed number is called as common difference. First term is A and common difference is D. Now this common difference can be positive, negative or 0. Let's take few examples. So let's say we have a common difference as 1. So 1, 2, 3, 4, 5, 6, 7 and so on, right? Now in this case the first term A is 1 and common difference is also 1 and that is positive. Now the other case can be 1, 0, -1, -2, -3, -4 and so on. Over here common difference is -1 but the first term is A, right? So it's a decreasing kind of arithmetic progression. Now one can also say that common difference is 0. So in that case 1, 1, 1, 1, 1. And although it doesn't have any kind of practical utility, but just for the sake of definition, we're defining that over here D is 0. Here D is -1, here D is 1, right? Now let's talk about general term and sum of AP. So general term is defined by Tn, right? Now, if we talk about T1, T2, T3, T4, and Tn. So T1 is A, right? T2 is A plus D. T3 is A plus 2D. Basically, we're adding D in every term, right? This is what we are doing. T4 is A plus 3D. Similarly, Tn would be, we have 0D with T1, 1D with T2, 2D with T3, 3D with T4. So that's why Tn would be, sorry, this A. Tn would be A plus n minus 1D, right? So what we can say, Tn equals to A plus n minus 1D. This is our general term. N is the number of terms in that AP. A is the first term, D is the common difference. Okay. And now if we talk about sum of AP, we'll denote that by Sn, right? That would be A plus A plus D, basically T2, plus A plus 2D, plus A plus n minus 1 D, right? This is Tn. So basically we are summing all the elements in that series, okay? Now what we can do, we can reverse this series and add, right? It would mean the same. Doesn't matter if we are writing this in the first place or this in the last place, doesn't matter, right? So let's do that. So we are writing the series in the reverse manner. A plus n minus 1D plus A plus n minus 2D, right? Plus A plus n minus 3D till A. Last term would be A over here, right? Now if we add both of them, we'll be getting 2Sn equals to, if you add these terms individually, what will be getting? This becomes 2A, this becomes n minus 1D, right? Now this becomes 2A, this is n minus 2D and plus D, that becomes n minus 1D. So similarly, all terms would become 2A plus n minus 1D. Basically, we have n terms which are same as 2A plus n minus 1D, right? So we've got 2Sn equals to n times 2A plus n minus 1D, right? So Sn becomes n by 2, 2A plus n minus 1D. Okay. Now, interestingly, this can be written as n by 2 a plus n minus 1d, right? Now this is our nth term, this is our first term, basically this is our last term and this is our first term. So what we can do, we can write this as n by 2 a plus l, where l denotes the last term, right? A is the first term, l is the last term. So what we can do, we can just add first term and last term and multiply it by n and divide by 2. So that would also mean the same, right? So you have to remember both of these formats for summation of AP. Now let's solve this question. The number of terms common to two APs 3, 7, 11 till 435 and 2, 9, 16 till 709 is. So let us first try to understand this example with the help of a smaller example, and then we'll proceed with this bigger one. Okay. So let's say we have two APs, 1, 3, 5, 7, 9, 11, 13, and so on. Okay. And now second AP is 1, 4, 7, 10, 13, 16, 19, 22, and so on. Right. You can see that first term is the common term between both of them. And now we can see that it has a difference of 2. It has a difference of 3. It has a common difference of 3. It has a common difference of 2. Right. But if we talk about the common terms, second common term is 7, right? We have a jump of 6 over here, right? 6 over here, we have a jump of 6 over here between two common terms. Now, how do we get that 6? That comes as the common LCM of 2 and 3, okay? 2 was the common difference of this one, 3 was the common difference of this one. So that's why the common terms have a common difference of 2 into 3, that is LCM of both of these common differences, right? We'll utilize this concept over here. So the first AP is 3, 7, 11, 15, 19, 23, 27, 31, and so on. And second AP is 2, 9, 16, 23, 30, 37, and so on. Okay. Now we can see that the first common term is 23 in both the APs, right? And this AP has a common difference of 4, right? This AP has a common difference of 4, and this AP has a common difference of 7. This has a common difference of 4. This has a common difference of 7. So if you talk about the common terms between both of these APs, that will have a common difference of 28. 7 into 4, basically LCM of 7 and 4, right? So the first term would be 23, second term would be 23 plus 28, that is 51, third term would be 51 plus 28, that is 79, and so on. So this would be our common AP. Now, if you look at the first AP, it is ending at 435. Second AP is ending at 709. So limiting case is provided by this one. We cannot have common terms beyond 435 because there is no term beyond 435, right? So this AP can maximum go till 435, right? We are not sure if 435 is included or not, but it can maximum go till 435. This is what we know, right? So if you want to write Tn for this new AP, that would be less than or equals to 435. Agreed, right? It can be equals to 435 or it's going to be lesser than 435, right? Now A equals to 23 over here, D equals to 28 over here. So we have to find out the number of terms. So Tn is what? A plus n minus 1, D is less than equals to 435, right? So A is 23 plus n minus 1, D is 28 less than equals to 435. Now this becomes 23 plus 28n minus 28. So it becomes 28n minus 5 less than equals to 435. So this would become n is less than equals to 440 by 28. If you find out this value, this would come out to be 15. Okay. Now let's solve this question. The Sn denote the sum of first n terms of an AP. If S2n equals to 3Sn, then S3n S2Sn is equals to. Okay. So the given thing over here is this. S2n equals to 3Sn. So S2n would be 2n by 2, 2a plus 2n minus 1d. Right. This is equals to 3 times Sn n by 2, 2a plus n minus 1d. Okay. If you open this, we can cancel out this n by 2. We're getting 4a plus 4nd minus 2d equals to 6a plus 3nd minus 3d. Okay. If we solve this one, we'll get 2a equals to nd plus d. This is our final outcome, right? Now we have to find S3n is to Sn. We have to find S3n is to Sn. S3n would be 3n by 2, 2a plus 3n minus 1 d, and Sn would be n by 2, 2a plus n minus 1 d. Now n by 2 gets cancelled out. What we have got 3 times 2a is nd plus d, so we can write that nd plus d plus this is 3nd minus d divided by 2a is nd plus d plus n minus 1, that is nd minus d. Now this d gets cancelled out. Now what we are left with, 3 times this becomes 4nd and this becomes 2nd. So this becomes 6. So B is the correct answer. Now let's solve this question. If the sum of first n terms of two APs are in the ratio 3n plus 8 is to 7n plus 15, then the ratio of their 12th term is, okay. So we have two APs over here. Let's say first AP is having n terms, first term as A1, common difference as D1. Second AP is having also n terms, common first term is A2 and common difference is D2, right? Now if you want to write out summation, ratio of summation based on this information, we can write n by 2 2a1 plus n minus 1 d1 divide by n by 2 2a2 plus n minus 1 d2. Now this is equals to 3n plus 8 divided by 7n plus 15, right? Now we can cancel out this term n by 2 n by 2. What we're left with? We're left with 2a1 plus n minus 1 d1 divided by 2a2 plus n minus 1 d2. This is equals to 3n plus 8 divided by 7n plus 15. Now what do we have to find? We have to find out the ratio of their 12th term. Ratio of their 12th term can be written as a1 plus 11 d1 divided by a2 plus 11 d2, right? This is what we can write for the ratio of their 12th term, a1 plus 12 minus 1 d1 divided by a2 plus 12 minus 1 d2, right? Now, how can we find out this ratio with the help of this information? Now, imagine if I put n equals to 23 over here. What if I put n equals to 23 over here? What I'll be getting? 2a1 plus 22 d1 divided by 2a2 plus 22 d2. Now, if I divide this entire expression by 2 in both numerator and denominator, I'll be getting same expression, right? This 2 gets cancelled out, this 22 and 22 gets cancelled out, basically it becomes 11 and 11 over here. So what I'm doing, I'm putting n equals to 23 over here. So this should reflect here as well, right? So this would become 3 into 23 plus 8 divided by 7 into 23 plus 15. This should be our final answer, right? Now let's talk about certain important results. The first one is sum of n natural numbers. It's not n natural numbers, it's first n natural numbers. Over here also first. Over here also first. Sum of first n natural numbers, sum of squares of first n natural numbers, sum of cubes of first n natural numbers, right? So the first one comes out to be n plus 1 by 2. This is the formula I have to remember. Now you can derive this with the help of an AP formula. 1 plus 2 plus 3 plus 4 plus 5 till n, right? So so first term is a over here, common difference is 1. So you can apply the summation of AP formula over here and you will find out that this comes out to be n plus 1 by 2, right? Now second one is n plus 1 2n plus 1 by 6, and third one comes out to be n plus 1 by 2 whole square. Now these two cannot be derived with the help of an AP. This can be derived with the help of an AP, but you have to remember all of them. You'll be using them in various places like limits, different kinds of progressions, etc., right? So you have to remember all of them. Now let's talk about one more result, that is Tn equals to Sn minus Sn minus 1. That's very simple. That's kind of intuitive, right? So Sn equals to T1 plus T2 plus T3 plus T4 till Tn minus 1 plus Tn, right? And Sn minus 1 would be T1 plus T2 plus T3 till Tn minus 1 over here, right? Now if you subtract both of them, everything gets cancelled out. What you're left with? Tn. So Sn minus 1 comes out to be Tn. Okay, very intuitive. Now let us solve this question. If Sn denotes the sum of n terms of an AP, then Sn plus 3 minus 3 Sn plus 2 plus 3 Sn plus 1 minus Sn equals 2. We know that this property can be used for consecutive terms. So one pair can be formed from here, one pair can be formed from here, and one pair can be formed from here. So let's break it down further. So the first term comes out to be Sn plus 3, and we can further break it down into two parts. It becomes Sn plus 2 minus 2Sn plus 2. We can also further break it down into two parts. This becomes 2 times Sn plus 1 plus Sn plus 1 and minus Sn, right? Now this is forming one pair. This comes out to be Sn plus 3 minus Sn plus 2. This one comes out to be Tn plus 3, right? Now this one comes out to be minus 2 times Tn plus 2. And this one comes out to be Tn plus 1, right? Now Tn plus 3 would be A plus N plus 2D. This would be minus 2 times A plus N plus 1D. And this would be A plus ND, right? Now this minus 2A, A gets cancelled out, and we have ND from here, we have minus 2 ND from here, and we have ND from here. So this and this also gets cancelled out. We have 2D from here, we have minus 2D from here. So this also gets cancelled out. So 0 comes out with the answer. So D is the correct answer. Okay. So today's lecture was till here only, and we'll be talking about GP in our next lecture. So let's meet in our next lecture. Thanks for watching.